to have you here with us today. Her and I greatly appreciate it. So, let me just go real quickly over the agenda that we plan to do today. So, my name is Edwin Robledo. As I said earlier, been working with Fusion and with Eagle for a little while now, primarily with Eagle, and in the last year and a half or so with Fusion 360. So, Jorge and I have been trying to learn it as fast as possible. That way you could get an understanding of what exactly is the idea behind of having an electromechanical design capabilities all under one platform. So we're going to go over a Fusion 360 overview, take a look at the schematic capabilities of Fusion 360, the circuit board, 3D PCB, talk a little bit about that library editor and the ECAD and MCAD collaboration. And we're going to be going through an example, a very simple example. That way you could really grasp all of the capabilities in designing in under one platform. Okay, so I'll go ahead and move forward here. So, when you're creating your next product, your next design, you're always going to need a host of applications. You're going to be using many tools for that. So you'll be using a mechanical tool, you're using an electronic tool, and other tools, simulation tool, e-cooling tools, and so forth. You're going to be using multiple tools. So with Fusion 360, we're able to integrate everything into one platform, a platform which is intelligent and allows you really easy collaboration, and it has unification because it really puts all the electronic design needs and all of your mechanical CAD design needs under one roof. So let's talk a little bit about, what are those challenges that you run into most when you're using a product in which you need some electronics, you need to make it smart and it has its mechanical requirements. So let's say, for example, if I was to gauge somebody in the chat, if you don't mind letting me know, if you're working on a product right now, what are those challenges that you run into when you need to hand off the electronic works over to the mechanical guy, or maybe you're the mechanical guy and you need to hand over all of the details of the mechanical design of the design over to electronics guy? That way he could lay it out right. So if you don't mind, if some of you want to answer, or give us some of the challenges that you run into when you're working with a mechanical engineer and an electronics engineer and all those other ones. So form factor, okay, Greg. 3D parts, yes. 3D parts, yes, that's big time. How about making the circuit board design area to be exactly what you need? That way you could hand it over to electronic design engineer. That way he makes sure that he lays out the board in the exact space where you need it to. Okay, that's one of the biggest ones. Right now, maybe some of you are using file conversions. You're either exporting a step file, or a lot of us use DXF files instead. So you may be exporting files for you to send that to the board house. But is that effective? Is that accurate? If the person uses a different application in which is interpreting that file in a different manner, maybe a different unit systems, do you have functional 3D for your components? Because the mechanical guys usually they're intense in 3D, so they have all that. But does your ECAD application able to repurpose those components that you have in 3D models? It's quite possible that it might. But not all ECAD applications are able to work with the intensity of using 3D models, as we'll be able to demonstrate today. Yeah, man.
Sorry for the interruption. I don't know if anybody else is seeing this, but your screen share is just stuck in saying Edwin Robledo has started screen sharing. Double click to enter full screen mode.
Oh, okay. So
that's what I'm seeing. I don't know if anybody else is seeing that. You can let us know through the chat if it looks good, or is it just me?
Let me know if you could see it now, Jorge.
No, everybody's okay. Ignore me. Everyone's okay. So it's algo conmigo. Don't worry about it. You keep rolling.
Are you able to see where it says design now?
I can't see anything on your screen, but everybody else can. So don't worry. If someone's not going to work, it's better that it's me.
Okay, let me make sure that I'm sharing the correct screen, though. So, yeah, it seems to be. I'm sharing the desktop. So maybe you just need to do a refresh or something like that, Jorge. Everybody should be seeing like a water bottle with some circuit boards in the middle of it. That's what everybody should be seeing. Oh, Jorge, just to let you know, Eric is saying that he logged out and logged back in and started to work for him. Okay, just to let you know.
Yeah, I might have to do that. So
Yeah. Okay. So yeah, Mike says he's seen the water bottle as well. So yeah, maybe log in, log out. Okay, we're good. Herman, he said that. Okay. So thank you guys. Appreciate that. So, you know, let's let's go ahead and move on now. We lost Jorge, but he'll come back in a minute. Now, when it comes to the design of any product that is going to be smart, of course, it's going to be a smart product. In other words, it's going to have some level of electronics. What exactly is that you need? You need a design environment that meets both the electrical as well as the mechanical requirements. Wouldn't that be, that's the preferred way of it. Be confident that you're working with the most recent version of the electrical and the mechanical design. Okay, making sure that whatever changes the electronic guy does, make sure that the mechanical guy has those changes as well. We're going to go over that a little bit and quickly respond to changes. Being able to make any type of modification and actually see that change and be able to share those changes with the rest of the team as well. Okay, so the integration of mechanical and electrical systems is traditionally a challenge. This is said by Mark Lyons, the VP of engineering over at Life Fuels, which is using Fusion 360 for the design of their product. So, it's time to integrate both teams. That way you have, it has too much problems because, the communication between them. So future kind of a design is kind of here, and that's called Fusion 360. We've been able to combine all of those needs that you have electronically and all of those needs that you have mechanically all under one platform, and a platform which is it's quite useful. It's cloud based, so you could walk up to any computer which has Fusion 360 installed, log in, and all your settings will be there, and you'll have access to all your files. So it's very portable. That way you could go over. Now, it also has, with your account with Fusion 360 subscription, it does include something called TeamViewer. Not TeamViewer. Fusion Team is what I want to say. It includes Fusion Team, which allows you to share your files in a way that those that don't have Fusion will be able to see what you're working on, see your progress, and actually make comments of your progress as well as needed, so they could take screenshots, but not only screenshots and send it to you in the email. No, it's actually taking screenshots, and any comments that you put there with the markups are actually stored in Fusion Team and their version. That way the team members can see your comments and actually see the progress of that product. Okay, so such as Elizabeth said over at VP, she's kind of the hardware. She is the hardware engineer. She said Fusion 360 allows our mechanical engineers and electronic engineers to work in a collaborative way to fit everything into a small space. In this case, it's a bottle. This is a bottle. It's a water bottle in which has 3 different cartridge containers, in which gives your water flavor, and it does have some vitamins, and you order the cartridges for them. And this is basically what the inner workings looks like a little bit. Okay, so let's take a look at the capabilities of Fusion 360. What do we have? So Fusion 360 is the schematic editor. As you know, it's the logical representation of how the circuit board is going to actually work. Then we have the PCB. Now, the nice thing is with Fusion 360, as well as you that have been using Eagle, you know that they work together. Therefore, modifications done to the schematic, modifications to the board are actually constantly handshaking. So any changes on one actually affect the other one. Now, whoops, let's go ahead. And then the building blocks of every design when it comes to electronic comes down to what? Libraries. As you know, creating your components is indispensable. Maybe accessing components that are available, it's great to have, but being able to make your own is amazing, because you could be certain that the components that you're making are correct. So we always ask you to be aware, if you're using components that you've downloaded from any other site, make sure that you check them, including the ones that we have. And I'm going to show you how to access many components that we have available in our repository as well. But we're going to go over the library editor. That way you could see how you could get those 3D models. Somebody made the comment earlier about, getting 3D models. We're going to go over that as well. So, and last but not least, and we're going to spend some time here on the 3D PCB editor. It's pretty powerful. There's some great some great tools that you could use in the PCB, the 3D PCB editor, which really make everything come together. And I'm going to be demonstrating that live when we go with Fusion 360. Okay. Now, in the schematic capture, yeah. So we have simulation. It includes spice simulation. So you could actually add a spice um, uh, spice files to your schematic symbols. That way you could run the simulation on them. We are able to handle analog, digital, and mixed signal as well. Now, one of the nice things that we have when you're working in Fusion, and this is maybe a comment for our Eagle users, is that when you're working in Fusion 360, everything is versioned. So when you're working on a schematic, every time you hit the save button, it actually gets versioned. It's very easy for you to end up with 40, 50 versions in a session, but that's okay, because just in case somebody else has, since Fusion 360 has great collaboration capabilities, so you could share your project with somebody else if you want them to work on it. It will actually tag each version according to whoever made the modifications. That way you could always promote an earlier version if necessary. Now, we have a large repository of parts, which our team of librarians are creating, but we've given access to many other corporations, such as distributors, as well as manufacturers, access to be able to place their own and manage their own components through our repository as well. So we have like Worth Electronics, Adafruit, SparkFun, TE Connectivity, and a lot more are actually being added as we continue to grow. Okay. Excellent. Now, let's work a little bit about a PCB editor. So first of all, we have real-time DRC. So as you make modifications to the board, if you have a violation, it lets you see that violation in true time. So there's no way of you really making a change to the PCB in which will not be manufacturable. Now, this is an option that could be turned off, of course. And I turn it off often because sometimes it's a little annoying because it's respecting DRC. Therefore, let's say from the board edge, by default, it's 40 mils from the board edge. Sometimes that's just too big for my board. So it kind of gets in my way. So I actually turn it off sometimes, but it does have live DRC. Being able to select a group of elements or assets, it's really easy. That command is always active. You just got to left click and start dragging. You could select independent components or select a group of components. Now, we have something, they've expanded. If you're an Eagle user, these are tools that you will not see in Eagle. They've expanded the manual routing capabilities in Fusion 360. There's a few other tools, like being able to route multiple lines, but you could influence the direction they're going to go into. So it's what we call guided multiple signal routing. Okay. Now, kind of neat, very useful, speeds up a lot of things. So if you got like a large bus and you got straight connections going from one component to the other one, you could just select it and kind of give it the direction. Let's say you want to do a little 45-degree bend because you want to place other bodies in that area. You could go around them and it influence that route as well. Now, one nice thing that we do have, Jorge, and I always like telling our friends about this one, and I think I was telling this to Eric the other day. I was talking with Eric not too long ago, and I was telling him about our new push and shove environment. Now, many of you may understand or may be able to think of push and shove as as a manual route tool. But in Fusion 360, it's actually an environment setting. With Fusion 360, I am able to set a push and shove environment in which if I'm moving parts, it will move traces and vias out of the way as well. Unrouted components, of course, okay? But it also works with manual routing. So it's an environment setting more than, yes, a routing environment. Now, creating your Gerber files, we have a couple options, and we would go over that today, which is one click. It will create all your Gerber files ready to, all zipped up, ready to go. Or if you need to make some manual changes to to your output, yes, because you use additional layers, you put some artwork in additional layers. No, you could always execute the CAM processor. That way you could use those layers as well. Now, if some of you are working with Eagle and Fusion 360, which works amazing. Now, one thing I just want to, this shares a difference, is that when you send your Eagle file over to, when you push it over the Fusion, the 3D PCB that you get is actually a canvas. In other words, all of your, the traces, the pads and the vias are not bodies. They're actually, it's like a bitmap file, but let's put it that way. It's like a picture what you have there. Now, when you're working with Fusion 360 and you work only in Fusion 360 PCB as well as 3D PCB, you're actually getting extruded bodies. Everything is an actual body. What is some of the benefits of that? Is that if you're going to be using e-cooling, those traces actually have materials assigned to them. Therefore, you could get, you could start using some of the e-cooling tools that we have in Fusion 360 as well. Okay. Now, a little bit about the library editor. It's an IPC compliant. It's this, and it kind of works exactly the way it works in Eagle. You got to create your schematic symbol, create your footprint, as well as you create your device. Now, we've also added to our calculator some hardware, some some nylon snap locks off and standoffs as well, the metal ones as well. And you're able to map 3D models, either they're in F3D format or they could be in F3D, which is F3D is the format used by Fusion 360, but you also could use step files. So if you upload your step files, which you wish to map to your components, that could be used as well. Okay. Now, we do have the calculator, which actually builds your components in a few clicks. And the nice thing is that it creates the footprint as well as the 3D model, all in the same step. And we have some we've made some modifications to it. It's working a little. There's some more variables that you could modify depending of how you're going to build it. So if you're going to do hand solder, you could make some changes to the pad sizes without affecting the 3D model or the IPC dimensions that you've entered as well. Now, as we said, post-processing is our CAM processor. We have two solutions, one click, or you could use a CAM processor. Now, our CAM processor always, when you select it, it will create, in addition to the Gerber files, which is 274X, but we also support X2, and it will generate the Exxon output as well. But in the same step, it will create the bill of materials as well as your pick and place ASCII files as well. We're using a very generic ASCII format in which can be easily adapted by whoever board house or bureau that you plan to use. They could just take that information and easily adapt that as well. Now, one nice thing of our CAM job is that if you set up a layer stack, let's say you have 4 layers, or 6 layers or more, no matter, we're able to handle up to 16 layers. It will automatically load a template according to your layer stack up. So that's kind of neat. It automatically will load it. So it takes a look at your DRC settings and it will load that for you. And of course, we have a preview, which you could take a look at what the board is actually going to look like, what you're going to get in the mail, if you're actually, unless they're going to be doing the populating for you. Now, earlier, I was telling you about Fusion Team and the collaboration tools. This is what it looks like. I'm not going to be able to get this in our live demo today, but I just wanted to take a snapshot of how this looks. And this is sharing with users that don't have Fusion 360. You send them a link of your project. They could take a look at it and they could do markups and make comments and take screenshots if necessary. And you will get an email every time somebody posts any comments on your design. Let's say you're missing parts, move a part, regardless of what the comments are going to be, those comments will actually be versioned and you'll be getting email confirmation of any commentary that is go. So you can see the progression of your project as well. Okay. Now, the 3D PCB, there's so many things that you could do with it. The 3D PCB, you could move parts. You could do the e-cooling from there. You could stem over to the e-cooling. You could see if you have any type of collisions with any hardware. As you see in the bottom right corner of this screenshot, you can see I have a little collision there with a pylon on the board. It's just kind of like hitting. I laid it out right dead at center. And I saw that. I took that as an advantage to take the screenshot. So now let's go ahead and it's all unified. And I put the screenshot because from the 2D PCB, you generate the 3D PCB, and they're tied together. Okay, they're tightly, changes from the 2D PCB and the 3D PCB, they're tightly tied. But from the 3D PCB, you could do all this. You could do e-cooling, you could do render, you could do CAM if you want to etch out your own PCBs. You could do the manufacturing, and you could insert that circuit board into the design workspace. And I'm going to just talk a little bit about some of the workflows that we've noticed that are commonly used when it comes to electromechanical design. Okay. And just to let you know, I will be addressing many of your questions towards the end, if I can, if necessary. Jorge, I know, will be manning the chat, so thank you, Jorge, for that. But towards the end, if there's anything that we need to show you live, we'll go ahead and address that as well. Now, so the idea here is, does the mechanical restrictions of the product designate the circuit board outline? If that's the case, there is one workflow that we can do with that. I could make a projection of any surface, and I could take that to my 2D PCB. That way I could lay out the board. Now, there are times that the PCB, you push that to the 3D PCB and hand that over to the mechanical engineer, and he will design the enclosure based on the PCB. We could handle that as well, all under the same platform. Or, and I have a feeling this is the one that's most commonly used, it's kind of flexible. In other words, you may have an enclosure that you wish to use, and the mechanical engineer sends that to you. But as you start laying out the circuit board, the electronic engineer may need other space, may need to change the shape. The battery doesn't fit. Therefore, he can make modifications to the board outline, send that over to the mechanical engineer, and then he could accommodate the enclosure accordingly. So it's flexible. So those are the three primary workflows that we've noticed and that we're trying to solve, everything under one roof of Fusion 360 as well. Now, so how do they cooperate? So as you know, I could go from the 3D PCB, I could go to the 2D PCB, so the 2D PCB and the 3D PCB, that's the right side of this drawing that I have here. Let me just mark this out. So from here to here, as you could see, they collaborate. They go in both directions. So I could actually make changes on the 3D PCB, and I will see the changes. Now I could capture the enclosure in the 3D in the mechanical workspace, and that will go to the 3D PCB. Now, what I cannot do is I could never go from the 2D PCB directly to the design workspace. That's not possible. It always has to go to the 3D PCB. This is what I wanted to show. So that's why you always have that latest version, because once the 3D PCB actually gets notification that the 2D made a change or the 3D made a change, and then the mechanical engineer in the design workspace is going to get that notification. That way he can update that as well. So I'm going to go ahead and let's go live with Fusion 360 now. That way I can show you a little bit how to access it. How we're doing on the chat, Jorge?
So far, so good, Ed. I've been able to answer any questions that have popped up, so it's clean right now.
Okay, excellent. That's awesome, man. How's the, I usually do an audio check. Is the audio check okay?
You sound perfect.
Oh, thank you.
Mío.
Awesome. Okay, so just want to check with the guys on the chat as well, making sure that everybody could hear me as well. I'm hoping everything is going okay. Just let me know if everything's sounding good. Okay. Oh, thank you, Herman. Appreciate that. Okay, excellent. I'll let Jorge answer the impedance. So we do have an auto router, but when it comes to impedance, not yet. But I'll let Jorge answer those questions there. Now, when you download and install Fusion 360, you're going to be getting some help file instructions in the beginning and some introductions. Once you install it, this is the first design space that you're going to see. This is the mechanical design space. This is where the mechanical engineer is going to do the majority of his work. This is where he's going to be drawing his sketches. This is where he's going to be defining everything that is needed on the design. So he'll be creating something like, let's say, for example, like this. Let me turn everything on here. So let me turn on all the bodies. That way you could see what this looks like. So this is where mechanical engineer will usually, actually they use sheet metal, I think, for this one. And this is where the mechanical engineer and the design workspace, that you could see the design workspace, it lets me know here. And here are the different design spaces. If you generative, render, animation. The render is actually pretty neat. It gives you a realistic view of the product that you're working with. It does a really, really good job. I would dare to say I've seen some renders look as nice as Keyshot as well. We have our animation, we have our simulation, which includes e-cooling simulation. There's many ways of doing simulation. It's kind of nice. I won't be able to cover that. I plan to do a presentation only on simulation. We have our manufacturing, that way you could create your manufacturing drawing, and then we have our drawings as well. Okay, now from here, what I wanted to show you is how do you access the electronic design? You would expect it to be here most probably. Now, to be able to access the electronic design capabilities in Fusion 360, you're going to select on the pull down menu and select where it says New Electronic Design. Okay. When we go to the electronic design, you're going to be what we call the electronic document. The electronic document is where you're going to be either selecting existing schematic and associate it to the, or link it to the, or reference a board that goes with it. If you already have an existing schematic or an existing board, what you're going to be using is here, link. If you are an Eagle user and you wish to upload your Eagle files, this is one way you could go about it. So I could here click on select my computer and navigate my hard drive and find any of my Eagle files, and it will upload them from there. Okay. So, and if you want to, if you have a board that references that board, and then you would select, once you select the schematic, you go here and you reference the board. Okay. Now, with that said, in this case, I'm going to actually start working with a brand new schematic. So to work on a brand new schematic, I will be clicking where it says the plus sign here, where it says new schematic. And this is going to bring me to the schematic editor. Now, please observe, this is the schematic editor, and I just want to do a real quick comparison. Take a look at the menu system that you have in the design workspace. You have your different tabs and your toolbars work accordingly. So it always works for the most common environment first, and it puts on the left-hand side the icons that are most commonly used in that environment, and it goes from left to right. Okay, that's how it works. So let's go over to the schematic that we just opened up. On the schematic, you're going to notice that we work with the exact same system. We have the design. Now we did on electronic, on the schematic side, as well as the secret report side, you'll notice that no matter which tab you select, some of the icons don't change, because you really need this no matter in which environment you are. These are quite necessary. Now, we've added here the most commonly used ones. So if there's more options that you want to appear, you could always click on the down arrow. You see, here's the info. But if you want zoom to fit to appear here, and then I could just select where it says view, and you see where those three dots here, and I could say I could pin it to my toolbar. Okay. In this case, I'm not going to use zoom to fit. I'm not going to pin it here because by default, it's pinned already to my panel down here, as you could see. It's already there. It's down there, zoom to fit. So there's many tools that you could use here that that are actually kind of duplicated up here. So always look down here. And now, and I'm going to tell you a little bit about more of how, when to use these. Of course, the undo and the redo and the show, even though I prefer to use the show from here as well. Now, there's multiple panels that we see here. There's a lot of panels going on. There's a lot of information, very useful information. First of all, we have the design manager. Now, I know that I have this brand new schematic, but I'm going to go over to schematic. I have started. It's a very simple example schematic. I'm going to move over because I want to show you data. I want to show you information in an environment that you would be working on. So I'm going to go to an existing board that I have, an existing schematic that I already have. Okay, this is my schematic. And notice that the environment. So the sheets, if you have multiple sheets, are going to be appearing down here on the bottom. They will be showing up down here. Okay, you have the design manager. Design manager, you could categorize it. I could view by parts. I could view by my connection, which are nets. And if you have any permanent groups defined, you could view by groups. If I select nets, then you'll see that this list changes to net classes. I have two net classes, which is the default one and the one for power. You could see your sheets. So if I select here my default one, and then down here, I see the names of all my nets. If I select any of them, it will try to zoom in on that net, as you see here. If you want to search for it, there's a search toolbar right there if you want to search for it. I could switch to parts, and then I could just go here, and now I could either select the part, or I could select the part I want to view. Now, when you select the part, any part that you see here, you get all the details for that component. What pins it has, the parent value, you get every detail that it was necessary for that part. You would get it right here, everything that you need, and where is it connected, on what net is connected. So it's really useful to have it here. It's very convenient. Now you could create filters as well. So if I go to filters, I could tell it, I'm going to look for all the components that have the letter R, and I could say, you know what, and I want all of the components that have that has a 3D model as well. So I say apply. Oh, I got to put an asterisk there. Sorry. R for resistor, asterisk, and they have 3D models. And it's showing me, it gave me a listing of all of the components that have the letter R, which are the resistors, and they have a 3D model assigned to it. If they don't have a 3D model, which is the case I think you would use it, that's where I've used it the most. If there's not a 3D model assigned to it, I'll select here, and it will give me a list of all the components that do not have 3D models. That way I know I have to go back and edit those parts. That way I could add 3D models to them as well. Okay. So this is very useful. Now, the nice thing is that here in the filter is I could save it. That way I could use it in my design. Only on this design, if I create a filter, as you could see, there's a lot of criteria for you to create the filters in library and module. There's a lot of criteria for you to use here. And I could use this in this design only because this filter that I'm creating is only applicable for this design. But if I want to use it for other designs, I could just go here and say select globally. So now when I load any other designs, I have access to those filters as well. Now, nice thing is that, let's say I've selected these parts. I have all these resistors here, and let's take a look at these resistors here. So they're all 0408s. Now, check this out. They're all 0408. So let's say, for example, I was to select all these components. Notice that here on the inspector, I could see all those resistors right here. If I select them all, they're using 0408s, right? 0402s. I can actually change which footprint I wish to use by using the replace part. And I could say, you know what? I want to use resistors. I'm going to go here and resistors US. And instead of using 0402s, I could say, you know what? I want to use 0805s. And all of these resistors would be switched over from a 0402 to a 0805 that easily. Okay, so I could actually easily just select all the components and go to the inspector and tell it I want to swap out which footprint I wish to use. Extremely convenient. So with only a few clicks, you're able to change all of your footprints from one format to another format. Useful, let's say you want to go from 0402s to 0805s, or you want to go from surface mount to through hole and so forth. So, and you don't want to do one at a time. Now, the selection filter. I just want to go. This is the last point where I'll do here before I move forward with this. Now, when you're selecting components, let's say for example, I have where it says attribute the selection filter. Here I could tell it what do I want to select, which portions that I want to select. So I could click on, let's say, any text. If I only want to be able to select text, so I would select text here. And if I have any text written, everything else is going to be ignored. So no matter what I click, it won't let me move anything at all because it only will allow me to move text because I only have text selected. If I want to select a polygon edge because I've drawn a polygon and I want to modify it, but I don't want to touch anything else, I would select polygon edge. So this gives you the capability of what can you move around on the design. You hit reset, that way everything becomes available again as well. Okay, and your sheets are down here on the left. Now, nice thing is, take a look here at this menu going on right here. As you see, this menu right there, it's letting me know is whatever command is currently active, it's letting me know what is my next step. What could I do at the stage? So that's one of the nice things that we have here, that this was actually added in a most recent version to Fusion 360 as well. Now, let's say I want to convert this over to my circuit board. I'm going to be selecting this icon right here, switch to PCB document. Okay. So I'll click here and this will create the board for me. It will use a board outline default. In this case, I just have this rectangle here. Okay. This is my PCB. Okay. So just to let you know, this is what the circuit board, and if I select here where it says switch to schematic, it's switching between that board and that schematic. And the reason it's switching between that board and that schematic is because I have an electronic document right here, which is associating that schematic and that circuit board. You see it right here. This is monitoring this schematic and this board. Okay, so that's what's going on. Now, nice thing is that you could use the electronic document and you could actually use it kind of as a preview. So there's the board and here's the schematic. Okay, so that's what was going on. This is controlling changes between schematic and board. Now, by default, the circuit board that's going to show up is going to have a default size. It's much larger than this. I just put this here just as an example for our current design that we're working with. Now, take a look at the user interface. You'll notice that it's very similar to the rest of the interface. So I have your designs, my documents, and it always from this point on is where it changes. You have your ERC. Now, if you're working with any board or any schematic and you're loading it from Eagle or maybe a different project from Fusion, I always recommend that you go to validate, run ERC, and always take a look at any errors and make sure that your board and schematic are consistent. I don't have enough words to explain how important that is. If at any point your board and schematic are no longer consistent, please stop whatever you're doing, and we need to figure out why they lost consistency. Okay. So let's go over to the board. So any components that I delete or add to the schematic are going to automatically show up on this circuit board that we have here. Now, these connections that you see here, these little yellow lines, these are the connections that were defined in the schematic. You define connections in the schematic using the net command, which is up on the top toolbar. If we go here under design, you'll see here where it says the net command, and that's the command that you use to define any connections. When you're defining connections, you're going to actually, when you get to the connecting point, when you select net, you'll notice that you get a bubble, kind of a, when you start. Okay, so sorry. And when you finish your connection, as you could see, you see that bubble that shows up there? That bubble's just letting me know that I'm actually connecting to a connecting point of a pin. Okay. Now, important detail is to never ever change the grid in the schematic. Always work on a 0.1 inch grid or the point 2.54 or 0.1 inch grid, whatever is easier for you. A 0.1 inch grid. Always work on the schematic. Just because there's no need for you to use different grids on the schematic. On the circuit board, you could always work with whatever grid is best needed to accommodate the layout of your circuit board. I'm going to switch to board. As you could see, we have the same panels. They work exactly the same way as they do in the schematic. You have your design manager, you have your inspector, you have a filters. The exact same way they worked on the schematic, that's exactly the same way they're going to work here on the board. Now, on the schematic side, I'm going to go back to the schematic. I'm going to use the add command if I needed to add components to my design. So I'm going to click here where it says add a part. Now, these are the libraries that I currently have available to me. So I have a small subset of libraries that I'm using. Now, and there's a search bar down that are in the toolbar you see here, search bar. So let's say I type in USB here, for example. I use the asterisk because I want to use wildcards. And so I could select asterisk USB and I get all of these response back of different USBs that I currently have at the libraries that I currently have available. Okay, I'll go ahead and shut this down. Now, notice that in the add dialog box, remember I'm switching from the add dialog box. If there's additional libraries that I would like to access, I'll select here where it says open library manager. How are we doing, Jorge, with the questions? Are guys okay?
So far, so good, Ed. I'm answering. We have a few in the chat that I'm taking care of now.
Excellent. So, hi, Sean. Hey, and Noel and Mike is here. Okay, excellent. Hey, guys, how are you? Hope everything is going well. So, Jorge, when you select on the open library, Mike and Eric, I think I was talking with Eric the other day. So when you select here where it says open library manager, it says in design. So these are in design. This tab is just letting me know from which library are being used for the components in the schematic. If we select in use, this list of components that you see here is the same list of components that we currently have in use. Okay. Now here's the interesting part. You see this little symbol that has these arrows that look like a circle. It's only a few of them. These arrows are letting me know that the author of this library has made updates. Either they're ours or by anybody else. It could be libraries that you're sharing with team members on your team. Somebody made a change in that library. It could be any shareable library that you have. It could even be an Eagle user. If you have an Eagle user and you're using managed libraries with them and you're sharing it through Fusion, you're going to get this little symbol letting you know that there's a modification to that library. If I select that library and I select update, it will update that library. You could just, left click and drag, select them all and update. Now, some of you may be asking, hey, Ed, but there's other parts that I want to access. There's other components I wish to use. No problem. I'll click on the available tab. In the available tab, you're going to see hundreds of more components that are available. I usually like to categorize them by managed library because the managed folder lets me know who worked on that library and it puts it in order. So here, this is a managed folder that we have. I think Jorge, myself, and Richard that we're sharing. I think Matt as well is in here. And then we have libraries that we created for DesignCon. And these are the ones called Eagle PCB. These are made by our team of engineers, our team of librarians. These are called Eagle PCB, and you may have all of these already. Some of my personal libraries. PCB Layout has a nice set of libraries. PCB Layout did a really good job. Almost the majority of the components have 3D models. The ones from, these are not public. Seed Studio, SparkFun. SparkFun they don't have 3D models on their parts. So you would have to edit that library. That way you could add 3D parts. On Worth Electronics, they've added many components. I mean, every component they make, it's here, Adafruit as well, and Nordic. Worth Electronics has done a good job at actually documenting their libraries really well. There's a lot of documentation, such as SparkFun as well. There's good documentation. And Worth Electronics is doing a really good job at adding 3D models. They're actually, they've done quite a bit when I've used their libraries. There's a lot of, and the metadata is really good. They show the links, the part number as well. So we're trying our best to do the same as well with all the components that we have. And we're expanding more companies to start contributing. Now, when you're selecting parts from the library, let's say I hit here our capacitors, and I'm going to expand the CUS. You notice that this icon right here, it's just letting you know that there's a 3D model associated to that component. Okay, so we have their schematic symbol, we have the footprint, and we have the 3D model. If there's libraries that don't have that, that little symbol, it's just letting you know that there is not a 3D model for it. These are actually uncompleted ones that I have right here. So, so just wanted to give you a heads up on the libraries that we currently have. They're doing a really good job at really taking a good look at our libraries, kind of taking out anything that's been outdated. And those that don't have 3D models, we're trying our best to go as fast as possible to add 3D models to them as well. We'll go into the library editor in a minute as well. Now, in the board layout editor, the first thing you want to do when you go over to the board layout editor usually is to work with your DRC. I think that's the most logical thing to do when you go over to the board. Oh, okay. Some of the guys, I think I'm going a little longer, so I'm sorry about that. I will just go. I just have to go a little bit more. So the DRC is where you're going to set up your layer configuration. How many layers are you going to be using? You're going to use blind buried vias, all of your clearances. Okay. Now let's go ahead and move over on the circuit board. And let's create this into a 3D PCB. How is that you do that? So here what you're going to do is the first thing I want to get this board outline. I need to get the correct board outline. So what I'm going to do is I'm going to go to the enclosure, which the engineer has already created. A lot of times the mechanical engineer will do this for us already. So what I'm going to do here, I'm going to turn off a few bodies because I want to be able to expose the surface where where the PCB is going to rest on. Okay, so I'm going to hide a couple of these bodies here. And here, the circuit board is actually going to be sitting on top of this body right here, on top of the standoff right here. And it's going to have this shape that you see here. Okay, and the way I'm going to handle this is that, first of all, I'm going to tell it, I want to create a sketch. I need to define a sketch profile. It's best to define a sketch profile first and convert that to the 3D PCB. I'm going to select right here where it says select plane. I'm going to select this is the surface I want to work on. Okay. And then once I select the surface, I want to project my surface. I want to actually project it. I'm going to project the surface. Then I'm going to be using. Okay. I'm going to shrink a little bit. I'm going to offset it because it's all the way to the edge of the board. So I'm going to select, and I'm just going to bring it down a little bit. 1.5, just a little bit. 1.6, like at least 1 millimeter. Okay. And I'm going to go ahead and click OK to the offset. And I'm going to keep on projecting the bodies that, let me delete. I don't need these bodies to be projected. I don't need none of this information. I don't need that. I don't need this. I don't need that either. So I want to project this. The drill holes, I do want to project those. Okay, let me see if that's done. And so I don't want those there. see if it lets me get rid of those. Okay. This one's giving me a hard time to delete, but I want to move forward. So, okay, very well. Now that I've created the sketch, I'm going to go ahead and finish my sketch. And I'm going to go ahead and I got to turn on the sketch layer. I'm going to select Create 3D PCB. And I'm going to select the surface which I want to sketch. I got this. Apparently, I have a couple of surfaces. Okay, so I'll just use this one for now for our example. I select this as my body I want to use. Now, if I would have sketched those holes better, I would have done a little bit more work. Now, I want to associate this to this circuit board right here. I want to actually associate that to this board here. Okay, so where did it go? Don't save. Okay, so let's save this. We'll call this 3D PCB. Okay, now I want to associate this to that circuit board that we're working on. So I'm going to click on Link to PCB. I want to reference. I want to reference that circuit board. I click here. And notice that now I've adopted that shape of that board. Now my circuit board has that shape and I have the drill holes with me. Now to complete the process to do the 3D PCB, I'm going to go ahead and push this back to the 3D PCB. And I like to recommend not to do the routing while you're doing this. Do the routing later because you never know if the mechanical engineer is actually going to be making any changes and you may have to do the route over again. So I like to recommend not to do the routing as of yet. That's why you see that board, it's kind of unrouted as of for now. As soon as I push it to the 2D, 3D PCB, it lets me know when things are synchronized. As you could see here, so here's my board. I've put all the parts that came up over here, as you could see now. Now I want to go ahead and I want to insert this on my enclosure. So let me save what I've accomplished so far. Okay, so I've completed. Let me go back to my here. So let's go to the panel. I'll save what I've accomplished here so far. As you could see, it refreshes here. Remember that we're always on the cloud. Remember, if you want to add anybody to this project to have access to the project, just click on people and you just got to add their email addresses right here and they'll have access to this project. If they're if they're Fusion 360 users, they'll get access to your project and you could assign them right there. It's that easy to collaborate. Now I'm going to insert my 3D PCB in here, and this is the best way I've been able to do it so far. I'm going to right click the component and I'm going to select Insert into Current Design. Now the orientation, that's something that we're working on. It's going to be slightly off. Now look at it, you see that it came in as a reference part, okay? So it's still referencing my 3D PCB. It's linked, okay? And I want to keep it linked. You're going to see why in a minute, okay? So I'm going to rotate this to put the right orientation. So I'm going to rotate it 90 degrees this way. Oops. Sorry, no. I'm going to go back to 0 here. Okay. Let me bring it up a little bit. That way I could see what I'm working with. Okay. So I'm going to rotate it this way, 90 degrees. Okay. And I want to rotate it 180 degrees, flip it. 80 degrees. Okay, perfect. I'm going to go ahead and click OK. Now, this is something that we're trying to fix, but so far, no, actually, this should work fine. So notice that this hole is the drill for this standoff right here. So to be able to easily align this, once I have it at the correct orientation, what I'm going to do is I'm going to define a joint, and I'm going to be using the bottom part of this hole. I'm going to select right here the bottom part of this hole. Let me zoom in a little bit. I'm going to use the bottom part of this hole right there. And I'm going to tell it, you know what? And that goes right here. Okay, so if I click OK, and there it is. It was that simple to pretty much align the board exactly where I want. So you'll see that the other standoffs actually line up correctly as well. Now, let's take a look at some of our hardware here. You'll notice that my double stack USBs are kind of are off. So here, what I'm going to need to do is I need to move these a little bit and kind of position them correctly. For sake of time, I'm just going to use an estimation, but usually you could use joints as well. But right now, the way you accomplish this is I'm going to save what I've accomplished so far, what I've done so far. And I'm just going to select here where it says, this is the PCB. This is the one. And you'll notice that the pencil shows up right here. It says edit in place. I'm going to select edit in place. Give it a minute. It takes a minute to kind of catch up. There it goes. When you see it goes in that wireframe format, now I'm in the 3D PCB mode now. I'm going to select move, and I'm going to select the body that I wish to move. And I'm going to go ahead and move it now. Okay. Okay. And I'll click OK. And let me just go ahead and select the other one. It needs to be moved as well. Now, when you're in this environment, you have all sorts of measuring tools. So you could take measurements. That way you move it exactly where it is. And you could type in here the movement, how much you want to move it to the left, to the right. You could be specific, okay? So you have the tools of, to really place the component exactly where it goes. So in this case, I think I need to go like 3.5 millimeters to get it correctly. Okay, I click OK. And I'll do one more I'll just do one more because I don't want to spend that much more time here. Because I want to see, I want to show you how does it react. So I just need to go like 0.5 here. Minus 0.5. Now, remember, we're in edit place mode. Notice that we have the menu up here on top, the little selection. It takes a projection of where we at right now. I'm going to click OK, but the process hasn't ended. I have to confirm all my changes and edit in place. Notice that it's up on top. Now I'm going to go ahead and click OK. The changes were accepted. See, so you see that they have this new position. Now here goes what we need to really cover. I'm going to save what I've accomplished so far. I'm going to save it. Okay. Once you save it, and we're working on making this a better experience. Now I'm going to save it. I'm going to close my 3D PCB. I'm going to close the 3D PCB. It automatically refreshes. I'm going to open up the 3D PCB. You see, because since this is cloud-based, when I close it, it writes it to the cloud. Now, when I reopen it, it's going to take my changes of my movement, and it's going to let me know that my 2D PCB and my 3D, because it took the changes I did on the design workspace. Now I'm going to go over to the 2D PCB, and now all of the components have now been shifted. So push the 3D PCB, the 2D PCB. Everything now has been shifted. Now I want to go back to my 3D PCB to complete the synchronization between the 2D and the 3D PCB. Okay. It's building the 3D, since there's changes in the 2D PCB, it's changing. It has to rebuild the 3D PCB again, one more time. Okay. Okay. Okay, now we have complete synchronization. Now let's return to the design workspace, because if we take a look here, it's going to let me know, look, there's some changes that I don't have. And the changes are going to happen because when I move the parts, you're going to see that the pad stayed behind. You'll notice that the connecting points actually stayed behind. So once we actually do complete the synchronization, once we select here, yeah, go ahead, finish the process. Now my 3D PCB and my 3D PCB, my 2D PCB and my 3D PCB and the design workspace are completely synchronized, and now we've got a good board, you see. You'll notice that the pads now are nicely lined up, everything lined up as expected. And I could continue doing that with this. This kind of concludes what I wanted to cover today about 3D PCB, you know, the design, the electronic design workspace in Fusion 360, as well as how is that we could use, leverage the 3D PCB capabilities in Fusion 360 to really fine tune my component placement. I'll go ahead and finish this by showing you really quick the library editor. So I'll go here to new electronic library. This is how you access the library editor. If I want to build a component, notice that it says symbol, device, symbol, footprint, and package. And for our example, I just want to create a package really quick. Create a package. It's going to be a brand new package. This is the IPC compliant calculator. It's going to show up as you see here. I could select any of these components. Oh, you select something really easy. Something really simple, a QFB. If you want to customize the footprint other than using the IPC compliant values from your spec sheet, I could do here, and I could actually change the size of the pad if necessary. Now, that's the size of the landing on the circuit board. It's not going to affect the 3D model, as I said earlier. I'll click on Update Preview. Here you'll be able to see the component actually build. It builds the component for you. But in addition of building the 3D model, it actually builds, and you see that it's actually building the model completely here. Okay, it's actually building it. It's actually creating the component. This is a 16 by 16 QFP. The dash lines that you see here, these hatch lines you see here, that's the actual size of the pad of the footprint. And then you have your 3D model. If this component was to have thermals, you would select the thermal pad option that you have here. And that way you could define the size of the thermal pad. And once if this is the component you wish to use, you could click on Finish. This will build the 3D model. It's going to use an IPC type of standard to name the pads, to name the component. You could change that name if you wish to whatever team criteria you wish to use. Once I click on Save, you'll notice that it shows up here. The footprint is going to show up here, and the footprint is going to show up here. If we double click on the footprint, there's the footprint as well. Well, I'll go ahead and open up the floor for Q&A now. Jorge, is there any other questions I should address? Any questions somebody may have?
So far, everything in the Q&A and in the chat has been answered. If there's any other questions, please feel free to put them in either one, and then I'll run them by Ed. But so far, I was able to get to everything.
So the only other thing that I like to always like a little tip is to remember that in the Fusion library symbol editor, when you're creating schematic symbols, we have here when they're under place, we have something called pin array. So if you're creating schematic symbols, if you're okay using standard names, you could click here where it says pin array. I could put, I only want components on the left, on the right. The base name, let's say it's going to be A. The pin count, let's say it's going to be 60. I want to put the name and the value and put that little rectangle like this, the little rectangle. A, so it's going to, use A is the base name, and then it'll put numbers as well there. And I'm going to go ahead and click OK. It puts the component that it built. I put it on my mouse cursor. Now I could go ahead and place it. Not many people know about that little tool. It's pretty neat. It's pretty useful to be able to, easily create your schematic symbols. We like to recommend that you place the component kind of in the, place the component on with the 0, marker on the center of it. That way it's real easy for you to find. Where does it go? Okay. And there it is. Okay. Okay. Well, I thank you everybody for joining us. I really appreciate that you joined and that you were here today.